Alright, let's go on to subtopic number 2, which is on the photoelectric effect. This is, I think, our last subtopic. Yes, so there's only 2 subtopics. So this subtopic ada a lot of theory lah. So the first one is you need to define photoelectric effect, explain the phenomenon of photoelectric effect by sketching a diagram of the photoelectric effect experimental setup. So this one, there is a possibility of it coming up in exam. And then you also have to define and determine the threshold frequency, work function, and stopping potential. Explain failure of classical theory to justify photoelectric effect. This one may or may not come out in PSPM. Okay, and then you have to analyze by using graph and equations the observations of photoelectric effect experiment in terms of the dependence of kinetic energy of photoelectron on the frequency of light, photoelectric current on intensity of incident light, work function and threshold frequency on the types of metal surface. And then lastly, you have to use the Einstein's photoelectric equation, which is this one. Okay, so now what is actually photoelectric effect? So photoelectric effect is defined as the emission of electron. Okay, so there is an electron being emitted from a surface of metal. Okay, so this is the metal. So we know that in a metal this consists of tons of electrons lah. Okay, so the photoelectric effect it causes this electron to to leave this metal surface lah. Okay, so when a radiation, electromagnetic radiation, touches this surface here, a photoelectron will come out of the metal surface. Okay, so this photoelectron is defined as the electron is defined as an electron emitted from the surface of the metal when electromagnetic radiation strikes its surface. Okay, so electron yang keluar dari this surface after an electromagnetic radiation sent to this surface here is known as photoelectron. Okay, so photoelectric experiment. So this experiment is done by Frank Hertz in 1887. So this figure is the schematic diagram of the experimental arrangement lah. That is our second learning outcomes. So you should somewhat sketch this diagram lah. Okay, this one. Okay, so the setup apparatus are as follows. So there are 2 conducting electrodes, which is the anode and cathode. So cathode is the negative electric potential, so this is negative, and the anode is the positive. Okay, so they are both encased in an evacuated tube, which is vacuum. Okay, so the monochromatic light of known frequency and intensity is incident on this cathode here. Okay, so when this light is with suitable frequency ataupun wavelength shines on this cathode, it causes photoelectrons to be emitted from this surface here. Okay, so these photoelectrons will be attracted to the anode because photoelectron is negatively charged. Okay, so because of their negative charge, they will be attracted to the positive charge, which is the anode. Okay, because of this movement of these photoelectrons to this anode here, it give rise to a photoelectric current. Okay, so ada current lah sebab ada pergerakan of electrons. Okay, so it is also known as photocurrent, which is measured by this galvanometer, which is this one. Okay, so if ada deflection means ada current. Okay, so when this positive voltage ataupun potential difference across the cathode and anode is increased, there would be more photoelectrons to reach the anode here. Okay, so lagi banyak photoelectrons come out from this cathode towards the anode, there will be a rise of photoelectric current lah. Okay, so as the positive voltage becomes sufficiently large, the photoelectric current will reach a maximum constant value. So that is Im lah. So this maximum constant value of current is known as the saturation current. Okay, so saturation current is the maximum constant value of photocurrent when all the photoelectrons have reached the anode. Okay, so there is no more electrons here, all of it goes to the anode. Okay, so time 2, photo saturation current is achieved lah. Okay, so if the positive voltage pula is gradually decreased, okay, sekarang ni tiada voltage sudah, the photoelectric current would also decrease lah. Okay, so even at zero voltage, there will be some photoelectrons with sufficient energy to reach the anode. Okay, so that and the photoelectric current flows is I naught lah. Okay, and finally, when the voltage is made negative, so sekarang the voltage is made negative by reversing the power supply. So sekarang ni kena reverse the power supply. Okay, so the photoelectric current would decrease even further to a very low value. Sebab most of the photoelectrons are repelled by anode because they're sekarang ni negative. Sekarang ni they're negative sebab power supply sini pun negative. Okay, alright. Ada lagi pula. So as the potential of the anode becomes more negative, less photoelectrons will reach the anode. Okay, so because of that, photocurrent would drop until it reaches zero lah. Okay, so when that happen, the electric potential is known as the stopping potential. Okay, so stopping potential is defined as the minimum value of negative voltage when there are no photoelectrons reaching the anode. Okay, and then the potential energy due to this retarding voltage would now equal to the maximum kinetic energy of the photoelectron. So this bit is important when they ask you to calculate what kinetic energy lah. That is the relationship. Okay, so M is the mass of electron, and the variation of this photoelectric current as a function of voltage is shown here. Okay, right, so that is that. And then let's look at the Einstein theory of photoelectric effect. So we know that a photon is a packet of electromagnetic radiation with particle-like characteristics and carries the energy E given by this. Okay, so this energy is not spread out through the medium, it is a packet, a bundle of energy lah. Okay, it's discrete. Okay, so that is the Einstein theory. So now, work function of a metal, it is defined as the minimum energy of electromagnetic radiation required to emit an electron from the surface. Okay, so we need to calculate the work function in order for us to emit an electron from the surface of a metal. Okay, so it all depends on the metal used. So the types of the formula is shown here, which is this one lah. This one yang important. So the F naught is what we call threshold frequency, and is defined as the minimum frequency of the electromagnetic radiation required to emit an electron from the surface of the metal. Okay, because the speed of light punya equation is this, we can also write this work function into this. Okay, so it all depends on what's available, what information is available. So either you use this ataupun this one. Okay, so this threshold wavelength ni, which is lambda naught, is defined as the maximum wavelength of the electromagnetic radiation required to emit an electron from the surface of the metal. Okay, okay, so that is that. And then Einstein photoelectric equation. So in the photoelectric effect, we know that Einstein summarized that some of the energy imparted by a photon is used to release an electron from the surface of a metal. Okay, so that is used to overcome the binding force of in between the electrons lah. Okay, and then the rest appears as the maximum kinetic energy of the emitted electron. So it is given by this one here. Okay, and then we know that E is also equal to HF. So substitute that into that equation, so we'll get the maximum kinetic energy, which is this one. So we know that the equation untuk Einstein photoelectric equation is this one, and we know that energy is also equal to HF and maximum kinetic energy is equal to this. We can then substitute each of this into this equation here, so we'll then get this equation here. Okay, so this is the Einstein photoelectric equation. Sorry, this one pun sama juga lah, cuma dia sudah kena substitute. Okay, and then since the maximum kinetic energy is equal to EVS, which is the retarding voltage, this is the charge of the electron. It can also be written as the one shown here. Okay, so there's two lah. Okay, so there are three cases where we need to use, there are three cases lah for the photoelectric equation, Einstein photoelectric equation. So the first case is when the energy is greater than the work function ataupun the frequency is greater than the threshold frequency. Okay, so if this is the case, electron is emitted with a maximum kinetic energy. Okay, and then the second case is where the energy is equal to the work function ataupun the frequency is equal to the threshold frequency. Okay, so if this is the case, the electron is emitted but maximum kinetic energy is still 0. Okay, so actually there is the electron is still being emitted. There is still electron lah keluar, tapi it's not moving. The maximum kinetic energy is equal to 0. Okay, and then the third case is when the energy is less than the work function ataupun the frequency is less than the threshold frequency. So if this is the case, no electron will be emitted. Okay, so it stays in the metal. Okay, alright, so that is the second subtopic.